In the last hundreds of years, the scale of London has changed enormously because of the social progress and the great requirement of human activity space. The relationship between human and nature is fractured caused by the rapid expansion of built environment. This phenomenon has led to a lot of urban issues such as the loss of biodiversity and the global pandemic. The virus-dominated pandemic has changed humans' activity. More and more city dwellers want to move out to a village, which inspires designers to think about designing from a human perspective. Our design has 4 chapters: urban scenario, design brief, biological research, and new urban life. By analyzing the population density and green space rate in London, a proximity map was generated between areas with low population density and high green space rate. We assuming the high density spots as ideal dwelling space. Geotweet map and carbon dioxide emission map after pandemic was used to represent the status of population density. The proximity map between them was generated. High density spots represent destination of human migration in real life, which coincides with the assumption of ideal dwelling space location. As a result, low population density and high green space rate are 2 main factors that affect migration. We intend to use biological intelligence to explore the relationship between landscape and built environment in post-pandemic age.
Based on the previous chapter, we analyze city from the 2 aspects of population density and green space density. We divide the city into a grade of 1 km multi 1 km size and respectively divide them into 3 grades, low, medium, and high, according to population density and green space density. Then overlay the maps of population density and green space density, and generate a map of 8 typologies, each with its own combination of population density and green space density. We can then design and change cities in a more targeted way. Among the 8 typologies, typology D and G has the characteristics of low population density and high green space rate. They are the areas with high potential of being new landscape. Then, we're going to rebuild the city with the help of creature. Physarum polycephalum, also called slime mold, is a single-celled organism with no definite shape. This organism scavenges for food, then develops a richly branched network structure. With the biological intelligence of slime molds, we use the new landscape points as food to reconstruct the urban landscape network. The growth process of slime molds is a process of the regeneration of the urban landscape network. The landscape pattern is regenerated by means of biointelligence and integrating with the city by using machine learning. Machine learning result shows how landscape pattern will be renewed in the next 100 years. In the final landscape regeneration pattern, 8 representative areas were selected based on the different typologies previously analyzed. Focusing on the scale of 1 km multi 1 km, the relationship between built environment and the landscape in different typologies is obtained. Based on the results of machine learning, the next step of urban and architectural design is going to be carried out.
Landscape and architecture coexist as a single entity. The design process consists of focusing on each typology and applying a specific regenerative process based on the biological research and machine learning algorithms. First, the machine learning algorithm allows for selecting an area of intervention, which will be the main driver for establishing a human habitable threshold. Within this threshold, several layers will allow for a wide variety of micro-habitats and human developments, creating a nested system of networks which will benefit from natural lighting and ventilation, as well as self-sustainable practices such as agriculture. Vertical elements will aid in the areas that require to suffice a higher demand in population density, integrating an outer skin with the landscape and creating the possibility for vertical farming. Integrating all these components will yield a tailored result for each city zone, allowing for a continuous development which increases in complexity with time. Landscape and architecture coexist as a single entity, where the lines between human and non-human are blurred, and a multiple assortment of activities can take place in any area of the development. The process is repeated using an algorithm that adapts to the needs of every typology, using variables such as area of influence, landscape and architecture height, as well as void size. It is possible to create an infinite number of iterations that diversify the results, while addressing the needs of the specific area of interest. From urban environment to biodynamic city.